Hey there. I'm going to do some of these problems. So this one, I'll just start right at the top, is grind 75. Some easy, some medium, some hards. And it covers a lot of important topics: arrays, binary search trees, dynamic programming, graphs. And I'll just tackle these. I haven't really done LeetCode in a while. So this is LeetCode 2sum. Given an array of integers num and an integer target, return indices of two numbers such that they add up to the target. I'll go ahead and change this real quick. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So the return value is going to be an array of two values. So you're going to get, as an input, a list of numbers. You're going to get a target, and you're going to try to find two numbers that sum up to that target. Let's just delete that. Guess I've done this before. How many years ago? 21 in JavaScript. Wonder why I did it in JavaScript. Okay, so this is a couple skills that you're going to need. Probably going to need just the ability to iterate through an array. So for loop, array iteration, right? You're going to have a list of numbers, and you're going to want to go through each one and be able to do something with it, right? Now, you can think about this in a brute force way. Brute force way is, let's say you have many numbers and you're trying to figure out the sum, and I imagine the brute force way is you have two pointers, right? So you have a for loop and a nested for loop, and that essentially creates the ability to check every combination, right? So let's say the upper for loop is the red, the inner for loop is the green. For each one of these x's, you check this, 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 and this, right? So let's just make these a little bit more clear. Imagine this is A, a B, a C, a D, an E, an F, and that's enough. So in the nested for loop example, the brute force example, you're going to check A plus B, A plus C, A plus D, A plus E, A plus F, right? And this is going to be the for loop that's inner. And then as this moves, your next loop is going to be this one. So you're going to check B plus C, B plus D, B plus E, B plus F, right? And the code for that is going to be like for X in this range where you start at 0 to the length of the array. You're going to do a for loop, and then for Y in range, and you're going to start at that X plus 1, and you're going to go to the length of the array. Then the sum equals X plus Y, and then we check the sum. We check it in some way, right? And this is going to be, well, I mean, I guess we could just write it because it's pretty simple, but if the sum is the target, then we know what we need to return, and we need to return an array of X and Y. And this would be the brute force nested for loop solution. We obviously don't want to do that. We're going to want to do something that's less costly, right? So we're going to consider a way that we can do this, iterate through this array, and instead of having these two pointers or a nested for loop, only have a single for loop, iterate it through in one pass, and target an O of n solution. And just keep in mind that we're using a computer, we have memory that we can access and that we can use. So we can create a dictionary, we create any type of data structure that we want and store some information that we can use, right? So if we had a for loop, right? So for x in this array, or for the value that we're looking at, can we consider storing valuable information, right? Which allows us to check against our stored information, right? Which is probably what we want to do. In the beginning of this for loop, check against our stored information, and then maybe store the info, right? So what type of checks could we want that could be useful? Now, A, it's not exactly a number, but if you had two things, right? I'm using green here. You had the target, and you had an A. Well, you can imagine that what we would want in the stored info is if there was something in here that was a target minus A, right? So let's imagine that target minus A is, I'm just going to make it A prime here. Target minus A is A prime. So let's say we have A prime, right? Somewhere in the past, back here, we stored an A prime. Well, if I encounter an A prime, I know that A prime is useful to me, right? That's the complement. That's the thing that I'm looking for. So what I would possibly be storing is the complement. And the complement is that target minus whatever it is, right? So the complement equals the target that I'm looking for minus A, and whatever the object is, I'm going to call it object for now, or it could be a set, right? It could be whatever. I'm going to call it C set, complement set, dot add this complement when we're storing it. But we also want a C set dot has the complement. So we actually have a choice here, right? So in here we can store the complement, or we can store the actual value that we looked at, and we can calculate the complement later, right? So as we go through this array, we can say we saw A, we saw B, we saw C, we saw D, we saw E, we saw F, and then we can just keep track of what we've seen, right? And this is basically a constant time lookup version of this array, because for me to find F in this array, I have to go all the way to the F, right? But if I create a constant time lookup version of this array, then it's very clear that on any lookup, I only need the key, right? Whereas searching through the array is going to be linear. So there's two options. I'm going to go with the first one because that's the one that I thought of first, where I store the complement, right? So we calculate the complement. Complement equals target minus A. If the C set has this complement that I'm looking for, then I know that so if it has it, then I know that I've seen something that would get me to the sum. Right? I've seen something that would get me to the sum. So if I've seen something that get me to the sum, I could actually just return out of this function, right? And I basically return to A, and then I return whatever target minus A was, right? Or I can return the complement. If I haven't, right? If I have not seen it, then let's just store the information, store that complement, and continue the for loop, right? So let me get all my comments correctly. Maybe I just make the comments gray so a little bit more clear what's not code. So in this for loop, complement equals this. If my storage has the complement, return out of the function, everything's done. Else, I want to add to the complement, and at this point, we're going to go back up the for loop, right? And that would be the code. And I would just code exactly what I drew here, right? So this would be, so for x in nums, well, first I want to create some set, right? So I believe in Python, you do something like set. I'm going to call that cset equals this, and I want to is that how you spell complement? I hope so. So the complement would be this target minus this x. It's not a, it's x. And if the cset dot has this complement, then I'm done, right? I return the x, and then I return the complement. Else, if it doesn't have the complement, well, I want to continue the iteration, mutating something that's outside of the loop, right? And what happens if it doesn't have it? You may assume that each input would have exactly one solution. Okay, so there's always going to be a solution. So this return, presumably, will always occur. It will always hit this return. And going to need that for Python. And okay, so this is my first time using Python set actually. So I believe, but I've definitely seen Python sets before. I believe you need something like this, complement in set. And hopefully this works. All right. And these are outputting. That's funny. You have to return the indices of the two numbers. Okay, so I'm returning not the indices, I'm returning the actual values. So I have to work with the indices in that case, right? So for I in range of length nums, the element at this point is going to be nums at I. And because indices matter, instead of using a set here, I'm going to call this complements. And instead of saving a set, or saving to the set, I'm going to, store two pieces of information. So complements at this complement is going to equal the indice. And then when I find this match, I'm not going to return the values, I'm going to return the indices. So I would be the indice I'm currently on, and then the complement indice will be complements at that complement value, right? So this is no longer, so I hope these variable names are clear. Some people may prefer complements to indice here, so it's a little bit more clear that this is this. So let's run this and try it. Yeah, so this is element right here. Okay, so this is part of the refactor. And all right, so this is outputting an empty array. And the target is 9. So what happened here? So on the iteration, the first element that I encounter is a 2, right? And what I save into the complements dictionary is 9 minus 2. So I save a 7. Okay. And because it's not in there, I save that 7 with the index of 0. And then for the next one, I see a 7. I calculate the complement, and that's 9. So I see a 7. And I should be matching on the, I shouldn't be matching on the complement. So I drew this wrong. I shouldn't be matching on the complement because the complement is the thing that I'm looking for next. So actually, and this is the confusing part about whether I'm saving the value or the complement. If I'm saving the complement, then once I see this as a value, then that's when I exit out. So I'm not matching complement to complement, right? So C set has complement. That's actually wrong. I'm not looking for the complement. I'm looking to see if the value matches. So what I should have done was instead of this, if complement in complements to indices, it should have been element. Because if the element is in there, then that's what matters the most, right? It's that the element so the element is 2, complement is 7, and then when the element is 7, I see that the complement is 7. I see something that I was looking for in the past. So it might have been confusing to save this as a complement. I could have saved this as a scene. So these are the ones that I've seen before. And that might have made this less error prone. So that's something to consider in the future, right? And, you know, the example for that would be, let's say for I in range of length nums, the element was nums at I, and I could have just, you know, the complement is the target minus the element. And what I did was I checked the existing thing for the complement when I should have used the element to check for to check if it's seen. So let's say numbers seen is a dictionary, and what that is an element to an index, let's call it. So if you have a number seen, right, you first see a 2, that's cool. You first see it, and then you see a 7, and you look and you get the complement of that, and then you could check if the complement matches anything that you've seen before, right? So if complement in nums seen, then return, else store, right? So this would have worked as well. And this may have been less error prone because it's just a little bit more clear, right? So I could write that as well. So num seen is a dictionary, and then we're going to go through this element is nums at I. The complement is target minus the element. And then if the complement is in the nums scene, then I want to return this and then the index, right? So the index would be the num scene at that complement value, or else I just want to continue, right? I want to continue and I want to store, right? This would be store, and this would be check, right? This would be checked, and this would be store, right? And store just means that num scene, I want to store this element, and I also want to save the index for that element. So this should be the same solution. Okay, somehow it's slower. So that's fine. I think there's some randomness to this. It's 47.9%. Now it's 67. Okay. So this is going to be, the runtime is linear. The space is going to be linear as well, because I'm keeping a dictionary of the element and the index. Thank you.